Hello, guys. Dr. K here again. Do you know that force is nothing but the rate of change of linear momentum? Did you know that? Do you know that's how Newton formulated his second law? The original way was using linear momentum. Let me show you. Let me show you the connection between force and linear momentum. Okay, everyone knows this equation. F net force, F net is equal to mass times acceleration, right? This is what we call Newton's second law. Now, acceleration is the change in velocity divided by time. So I'm going to write it in this way. Final velocity minus the initial velocity divided by the time interval. Divided by the time interval. Okay, so because this is the change in velocity divided by the time interval, that's what we call the acceleration. Now look, m is a constant. I'm going to distribute the m inside this parenthesis. And then look what we have. M times V final minus M times V initial divided by delta t. Divided by delta t. And what is M times V? M times E, that's what we call linear momentum. So this is final linear momentum minus the initial linear momentum divided by time. Divided by time. And this is nothing but the numerator is nothing but the change in linear momentum, delta p. Delta p over delta t. And that's our right hand side. And look, what's our left hand side? That's the net force. So net force is actually the rate of change of linear momentum. This is another way of writing Newton's second law. You are familiar with this version of Newton's second law? And now we have another version of Newton's second law in terms of rate of change of linear momentum. So instead of saying if there's a net force, there's an acceleration, you can say if there's a net force, then the linear momentum is going to change with respect to time. Okay, so this is how you show that net force is nothing but the rate of change in linear momentum. These two are the same. They are the same. They are like two ways of saying Newton's second law.